Okay, so I got a request for a video for problem 3.72. Let's see here. 3.72, and it's on page 119. This is a Mastering Chemistry problem, and it's a bit of a doozy. Just a minute here. It's a little bit light and scrap here. Okay. So, problem 3.72, and it reads, tartaric acid is the white powdery substance, blah, 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 blah. Combustion analysis shows that it has a mass, a mass sample of some sample is equal to 12.01 grams, and it contains only carbon, hydrogen, and oxygen. Okay, so I'm going to say C sub X, H sub Y, O sub Z, and obviously when I know what those are, that's when I'm going to know my empirical formula, right? And it says when we burn this stuff, this is combustion analysis, we get a mass of carbon dioxide is 14.08 grams of carbon dioxide. Okay, and then the mass of water that comes off is equal to 4.32 grams. 4.32 grams. Okay, so before I get started, I stop and think to myself, what's going on here? Once I know how many moles of this 12 grams, how many moles is carbon, and how then I'm going to know what X is. And when I know how many moles of this is hydrogen, I'm going to know what Y is, right? And oxygen is the same thing. So what I'm going to do, first of all, is I'm going to find the mass of all of these guys that comes off, right? So the mass of carbon, you know, when you do combustion analysis, what you're going to do is you're going to do combustion analysis is that plus O2 gives CO2 plus water. And I'm guessing that you would know that just by looking it up. Okay, that's in the book under elemental analysis, and you have to know that. We're going to combine with oxygen from the air, and we're going to get carbon dioxide and water. So every mole of oxygen that I get off of here comes from here. And every 2 moles of hydrogen that I get off comes from here. Okay, so knowing that, first of all, I'm going to find the mass of each of these. So the mass of carbon, right? Whatever carbon I get from here is going to come off of here, okay? So the mass of carbon is going to be the grams of carbon per mole of carbon, right? Mole of carbon per mole of carbon dioxide, because I'm coming off of here. Mole of carbon dioxide, grams of carbon dioxide, because that's what I started with, right? And then grams of carbon dioxide. Okay, that's going to give me my grams of carbon. You might want to pause the video and look at that. I'm going to ask you to pause it and look at those and predict what numbers go where. Okay? But before I do anything else, let me go on and set up my hydrogen. All of my hydrogens come from here, right? Because with combustion analysis, I'm only adding oxygen. So my grams of hydrogen is what I'm going to find next. Okay, so my grams of hydrogen is going to be grams of hydrogen per mole of hydrogen. Mole of hydrogen per mole of H2O. Mole of H2O per gram of H2O. And then grams of H2O. Right? And this, of course, is 4.32. This is 14.08. And these are all my conversion factors, which are going to, that many grams of carbon dioxide are going to contain this many grams of carbon. This many grams of H2O are going to contain that many grams of hydrogen, right? Okay, so now that I've got that, I'm going to say my grams of oxygen. Right now, you can't just do first of all, we don't have another thing. We already took care of those two. Boom, boom. We don't have a way of finding how much oxygen comes from here, but we do know that this thing only has carbon, hydrogen, and oxygen in it. And so this is going to be 12.01 grams minus box minus circle. That's how many grams of oxygen are going to be. Okay? And then after we get to that point, Then we're going to do what we did in class in terms of carbon, oxygen, hydrogen, grams, formula weight, moles, and prime, and so on. Now this is a long problem, but I'm going to go ahead and I want to do it with you. I want to do it on the video so that you can have the reward for that. It's a little unrewarding if you set something up and don't figure it out. So let's do this. Okay, what are the grams and moles that go here to convert this? It's going to be 1 mole, right, for how many grams? 44 grams. I'm going to look up the actual number for carbon dioxide. Carbon dioxide, it's going to be 12.011 times 1 plus 2 times 16.00. Okay, so let's figure out what that is. 12.011, enter. 44.011. 0.011. Okay? Now how many moles of carbon for every mole of carbon dioxide? Hopefully you put these numbers in. If you didn't put these numbers in, pause the video here and go in front of me. Well, it's a 1-to-1, right? For every mole of carbon dioxide, there's only 1 mole of carbon. What about grams of carbon for mole of carbon? And it's 12.011 grams for every 1 mole. Okay, so let's figure out this number box. It is 3.843. 3.842559, and so on. Okay, and that number is going to go here. Let's do this one now. Grams of the formula weight of water is 2 times 1.008 plus 1 times 1600 is equal to 1.008. Enter 2 times 18.016. 18.016 grams per mole. How many moles of hydrogen for every mole of water? 2 to 1, right? Can you see there's 2 of them here? Okay, and then grams per mole, that's 1.008 per 1. Okay. Okay, so this should give you 0.48341 and so on, is what circle is, okay? This is going to be about 3.843. This is going to be about 0.4834. And so our grams of oxygen. But before I do this, I'm going to go through and check my math again real quickly, all right? Okay. Okay, I just checked that one and it looks like it's good. Check that one, looks like it's good. Okay, good. All right. So then this gives me 7.684 grams of oxygen. Okay, now I'm ready to calculate this like we did in class today. The grams of carbon is 3.843. Grams of oxygen is 0.4834. And grams of, I don't know if I said that right. Wait. This is oxygen and that's hydrogen. That was hydrogen. I just read it as oxygen. Okay. So I switch these here. 7.684. Okay. Now to get the empirical formula, I have to divide by the formula weight. This is 12.011. This is 1.008. 16.00. 0.48, 0.4834. This is 0.480, 0.480, and 3.843. This is 0.32, 0.32. Okay, so now I go through and divide everything by the lowest number. This goes to 1. This goes to 1.5. And this is going to go to 1.5 also. It's the same number. Okay, so n double prime. What's the fractional portion of this number? It's 1/2. So if I multiply everything by 2, I'm going to get 2, 3, and 3. Okay, so it looks like the empirical formula is C2H3O3. Wow. Hope that's helpful. Please consider going back and working through it again. I do believe that we followed a fairly linear trajectory with this solution, and it just turns out to be a complicated problem. But we reviewed a lot of things in there, including calculating formula weights. Okay, good luck.